All right, welcome back. So let's take a look at why the order of operations is so important. Okay, so if you're looking over that way, whoop whoop. So at scenario A, let me get the mouse over here. Scenario A, right here. Oh no. Okay, scenario A. So what you'll notice here is they did this problem the way that you may have or that somebody may have that doesn't know the order of operations, right? They added first. They added 4 plus 12 and they got 16. And 16 times 2 is 32. Is that what we see here? Do we see 32 eggs? No. So if we didn't follow the order of operations, it could never get to that answer. That doesn't work with this picture. There's no way that we can make 32 eggs when we don't even have 32 eggs. But in this situation, because they tried to add before they multiplied, remember, you have to multiply and divide before you can add and subtract. All right, they got the wrong answer. Now, this person remembered that you multiply and divide before you add and subtract. So what they did is they multiplied 12 times 2 and got 24 and were able to add 4 plus 24, which gave them the correct answer of 28. So you can see how if you don't follow the order of operations, you can get an answer that doesn't match the situation. All right. Once again, this is why the order of operations is important, because then we get the same answer every time. All right. So we can look at kind of the example that we got over here. That was the other one that they did. So 12 times 2 or 2 times 12 plus 4. Once again, you can see one of these is incorrect. One of these answers does not work. Which one is it? Scenario B is way off. If you look at that picture, you see 28 eggs. You can count them. You can count them 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 25, 26, 27, 28. 28 eggs, right? But look what happens if they add before they multiply. If you added first, you'd get 6, and 12 times 6 is 72, and that's not the situation over here. So that's important as well. All right, so let's take a look at the next part. Might be the final part. Okay, they're giving us a long one. So not only did they give us a longer one, a longer expression, I should stop calling it a one, it's an expression. And again, why is it an expression versus an equation? Because it doesn't have an equal sign. Yes, you can solve a problem with no equal sign. All right, so if we're looking at this, once again, we look at BPMA. There's no brackets. There's no parentheses. So right now we just really need to focus on making sure that our multiplication and division is done before our addition and subtraction. I mean, it doesn't focus very well, so maybe I'll put it back down. Okay, so in this situation, of course, we'd have to do multiplication first. But check this out. Because of the order of operations, you could make a long multi-step word problem work with one expression. So look at this, for instance. It says Jay has 16 light bulbs. He buys 4 3-packs. 2 of the light bulbs he buys break on the way home. I must have fallen, poor Jay. How many light bulbs does he have in all? All right, so he started with 16. All right. And then he buys 4 3-packs. And then 2 of the light bulbs he buys break on the way home. All right. So he already has the 16. Remember that we would have to do multiplication and division first in this problem. So the first thing that you would do is 4 times 3. 4 times 3 is 12. We would copy down anything that we didn't use. So we didn't use the 16, we didn't use this plus, we didn't use the minus, and we didn't use the 2. All right. But we did know that we had to get 4 3-packs, and we didn't just add 16 plus 4. If we added 16 plus 4 right away, it wouldn't have followed our word problem. So now, if we just follow this left to right at this point, we can find out how many light bulbs that Jay has, and then take away the 2 to figure out how many he has left. So we can do that one step at a time. He ends up with 26 light bulbs, all done in one expression.